This is video 8 in 11. Now we consider the second smoothing method. It is called smoothing splice. In this method, we use the f to represent the smooth curve. And this smooth curve in this method must be continuous and integrable first and second derivatives. The smooth curve is searched for by maximizing these objective functions. So the first term in this objective function is the difference between the crude values and the smooth values. The first term involves the difference between these, or we can understand this term as the distance between the crude values and smooth values. So we want this distance as small as possible. And the second term is about the smoothness for this smooth curve. So this penalty term, we call it as the penalty term. These penalty terms consider the second derivatives of the smooth curve. In other words, the smoothness of the smooth curve is imposed by considering its second derivatives. So this penalty term requires that this f function is continuous and integrable first and second derivatives. Lambda here is the smoothing parameters. It controls the smoothness and the goodness of fit for this curve. Larger values for lambda gives more smoothness, gives more smooth curve. Okay, this lambda value can be determined by the cross-validation method, exactly the same in this here cross-validation estimation method, exactly the same is the procedure here. Okay, now let's come back to the code. Okay, we still use the scatter plot as in the kernel smooth method, and we'll give its true curve represented by the black curve. The smooth value by this spline method is given by the smooth.spline function in R. So in these functions, the first input is the x values, and the second input is the crude values. And the students can look much detail about this function by using the help function to look inside some details. And if you do not specify any smoothing parameters, then this function estimates the smoothing parameters automatically by using the cross-validation method. Okay, here I do not specify anything about the smoothing parameters because I want the smoothing parameters calculated automatically by using the cross-validation method. Then it gives us the red curve. Okay, if we specify some smoothing parameters, here I use df equal to. So it gives us the larger smoothing values. The df here means degree of freedom. It is a kind of smoothing parameter. It plays a similar role with the smoothing parameters in smoothing the curves. df equals to is very large smoothing parameters. It gives us the blue curve. It is very smooth. It is a straight line.